what I'm looking at right now is, again, the single pane of glass interface we talked about. It's the ability to look at information across all of our collection from all of our devices. And I'm loading simply a box that I'm running in a lab environment, so you're going to see enterprise data, but it's been generated across our platform. The information we're seeing is very relevant in many cases to simple event analysis, and I'll show you a very simple event view first. I'm looking at all events that were collected today, 109,000 of them from a number of different devices and platforms. My application data monitor and my my database activity monitor are present in generating event data. What I'm looking at right now is the event data that's been collected, and let's talk about a few use cases that were described earlier in terms of content and context. Adding context is something that most platforms do, and again, we talk about context being very simply, I'm going to look at events not by volume of activity, but the context that's relevant for my use case right now is maybe the user activity. So the ability to pivot on this data and say, show me all user behaviors. And so here are all of those 109,000 events now shown by the relevance of the user that generated the event activity. And of course, if you're dealing with user information, users are kept in most cases in storage locations like Active Directory. So the ability for us to leverage your existing Active Directory implementation allows you to very quickly pull up your AD groups and memberships and say, I want to see all of this information, but I want to filter it by only those events generated by admins. So I can add the admin qualifier, hit refresh, and now it goes from 109,000 events very quickly to 5,900 events that are relevant to just the administrative activities. So one area of context is things like the identity of the user. And identity of the user can be arrived at by a number of lookups. More importantly, we're collecting event data from a number of sources, things like Active Directory and other single sign-on platforms, other authoritative sources for user identity and information. And the ability to normalize identity as well is something that's a function of the product. So you can look at things by a user regardless of where he came in or what IP address he had today, regardless of DHCP assignments. I can say I want to see everything from administrator in the current day, but I can now say that administrator came in from these 3 IP addresses over the course of today. I can go even broader and say, show me everything from last week. And very quickly it'll be the same information for the context of the administrator, 68,000 events, but now you're looking at all of the sources that was represented by the administrative activity. So context is something that everyone's been doing for a long time, but we do a few more things with contextual alignment that I think is quite unique. It's the ability to automatically start building relationships across the view with data and look at the relevant queries that are resulting from selections I make. So for instance, if I wanted to look at all root activity, I click on root, and what you'll see are all of the other panels will automatically update and refresh with the new query result sets that show me what this user root has done. And so it automatically builds the relationships that we typically had to go and build SQL queries for. And so typically a security operations or professional is not going to be a SQL expert, but they were required to be such to build these relationships with the complex table structures and building the appropriate joins and where clauses that were necessary, to get that process done. So I'm looking now at a simple process that does it all for you. And just to exemplify that one more way, I'm going to show you how this would be built from scratch if I needed to for a specific use case of either incident response or possible fraud. So I'm going to click right here, and I'm going to show you the ability to actually customize the entire platform and use it for the use case that is relevant for that exact behavior. So if I'm looking at something that is very specifically, let's say, a fraudulent activity, I might start with the concept of what the event categories were. And so this is a listing. Very quickly, I built one query in real time that shows me all of last week's events broken down and grouped by event category. These are categories in our normalization taxonomy. So what you're looking at now, we've had a number of threats or activities classified by certain event characteristics. And if I wanted to, for instance, look at these 63,000 suspicious events, I can simply select just that event category, drill down into the next index of the data that's shown here, which will show me the breakdown of those 63,000 events in detail. Here is a list of those 63,000 events that make up the suspicious activity category. Now, if I change my mind, by the way, and I change this to exploit, and I'm now looking for all exploits occurring last week, simply by clicking on the exploit object, you'll see that this lower panel will also update, and it's showing you now the 89,000 exploits. Because I've made a change here, it automatically reflects that downstream. So again, if we're looking for a use case of, let's say, fraudulent activity, we might be looking for things like suspicious behaviors. And fraud is probably best performed by the concept of correlation. Because a correlated activity is going to be something that watches for patterns, and fraudulent activity is typically identified by its pattern identifiers. And the patterns we'll deal with will be things like account logouts or account logging failures, successful account activity, as well as changes to account behaviors. But if I'm looking at this right now, I'm looking for the suspicious activity, in this case broken down here. I want to see all of the SSH possible brute forces, 186. And my next question would be, from a forensics perspective, where did these events come from? And that is a question best answered by the source IP list. So again, I just in real time asked for the list of IP addresses that were sourcing the possible SSH brute force attacks in the period of time of last week, and I very quickly got a list of 186 event source IPs. Next question would be, where were those sources headed? Who were the targets of the potential attacks? And that, if I were asking the data of the question, the data that would respond with the right answer would be the list of guest IPs, and I've now got a list of very discrete events and destinations. This was all done with very simple event analysis, simply drilling down into the data that I had available to me. But my next question might be, okay, if one of these machines were compromised, where is the threat going to expand at? Where will the attack proliferation occur? With flow information, I also have the ability to look at the characteristic session data. This is application session, or more importantly, network session activity. But flow information is one area of content that also adds a lot of forensic value. It says if these machines were in fact compromised, the next question I ask is, where did they go next? Because they should now be considered suspect hosts to everybody they talk to. This is one way of achieving that, by looking inside of the event data to identify threat patterns, and then more importantly the flow data to see threat relevance and activity that might be in common between two devices. So this was one use case for just building the UI around what I need done to make it work. But if I'm trying to build the understanding of what event information leads me to believe that suspicious behavior is taking place, that would really probably best be shown inside of a product like the database event activity logs or the application event activity logs. But just as a start, let's look at our database suspicious activities that have occurred over a period of time. And what you're seeing here are a number of suspicious activities being identified by our database activity monitor. And let's see what some of these suspicious activities were. And let's look at events from, how about today, just to make it a little easier for everyone to see only a few events on 1,800 events. We'll make it easy. And so, actually, we've had none today. So let's just look at the last 2 days. So what we're seeing now are the event activities, and you can see here unknown applications. I've got unwanted programs that have been seen from database transactions. Those are probably not what I would typically expect to see from database events. And so I'm not quite sure what they mean to me yet, so I can simply drill in on them if I need to. But those events are probably not going to be helpful to us. Just knowing what I know about the context of those events, this window of time might not be most appropriate. What we're looking at is again, database sessions. Let's look at it from a larger, more application-specific context. And that's if we were trying to build correlation rules that spotted certain behaviors that we would be concerned about most. What we're looking at now is the policy. This policy is what we use to define the configuration and parameters for detection of all of our solutions. I'm going to focus a little bit on the correlation policy, but I'm also going to expose the database policy and the application policy very quickly, because you also see how customizable those solutions are. And in fact, I'll start with, let's say, the one we referred to earlier. The SQL database policy looks like this, and this is just the one for Microsoft SQL. We have policies for all the database implementations we support, but it watches for standard transactions that most people would be aware of in a simple log event. So when you see logs being created for things like databases that are dropped, and you're seeing DML transactions for delete, insert, select, and updates, those are things that any audit trail would tell you. But what if you need to see a little more detail about the content or the relevance of the query itself? So if I'm looking at things like how many events or records were returned, I have default rules that say this is a large result row trigger. if I define this as my threshold of being 1,000 rows in my high point, I can say that if any activity is seen where a row count exceeds the 1,000 record threshold here, that could be exposed to me as a potential data loss or reason to inquire further. So that alone might be a very simple rule, but we can also add to that rule other things that might be relevant for your exact use case. So for instance, I can add a new rule in this context, and inside this new rule, I can simply build this in and say, if I see this result row count of 1,000 exceeding my threshold, but if it has come from a IP address who belongs to a certain group in my Active Directory, and maybe I'm trying to define that the rule set should really be not just anybody asking for and retrieving a record set of 1,000 rows, but if I see a certain user or a certain group of users who shouldn't be querying the database to begin with, if I see them start looking for other, or seeing them perform transactions that might be suspect, that might be the next qualifying pattern that I would add. So if a username is equal to a certain value. We also have all of our Active Directory integrations that allow you to do that in our correlation rule you'll see in a second. You can just grab things out of the AD set and containers. So the ability to tie these rules together to make them more relevant is probably the next thing to show, and that's the fact that while we can spot and determine these transaction behaviors on a per database event basis, the ability to watch for those things in patterns in correlation rule sets is really what I think makes a solution like this unique, is the ability to take that data we just learned and make it into something that's meaningful. So let's look at how we would build a very simple rule watching for a specific use case pattern that would be associated with a potential data loss. I can look for certain activities performed by users. I can look for commands being issued. So if I see a command issued that is in my list of maybe known commands that are pulling data, but I'll just add a very quick one, is to select all. If the command I'm looking for is a select star, that might be the command that is the trigger for me to start believing that something is going to be amiss, or I can look at the individual event that would be generated by that 1,000 record rule set. But if I see this occur, and let's say I also see, so I'll make this a required and I also see users belonging to a group that is not in my list of admins. Maybe it's the admins that are allowed, and anybody other than admin should not be doing this. So I'm now saying that if it's not an admin, and they're performing a select all, and these are happening in a certain order or context, I can also say, or, put this whole thing in a big or if the IP address that he's coming from is outside, let's say, the geolocation policy for the U.S. So even if it's an admin, he can't be doing this from an IP address that is known to be outside the U.S. as a geolocation, or maybe I could just put it as outside my local subnet in terms of my local usage. So all those things can be done in terms of just dragging and dropping and building this context of a rule. But when you start dealing with content inside of things, that's where you start having the relevance for the AVM, the application visibility. And so the application visibility rule set actually allows you to build, like these have actual content disclaimers or parameters that watch for very specific things, like in one of these cases, the email being sent out containing the Coke recipe. That's always an interesting one to play with. But the reality is it's the ability to watch for and look up in either dictionary lookups. So a dictionary lookup would allow you to have an external address or a field list that can be referenced internally for the rule. And then I can say if, let's say, the email protocol is a MIME message containing an anomaly of some value, or I can simply just say that the object in question is a zip file, or that the properties of the device or object is described as a certain protocol or having, let's say, an object size greater than a number. So here's how you build your defining policy attributes for what make up an event that would be suspicious or malicious, or in this case, potential data loss. I can start watching for things with the right context and attributes that would define it to be one of those triggers. We're coming up to the end. I want to make sure we leave enough time for questions and answers. So I'll and hopefully if anybody has questions, they can type them in, or they have been doing so. I haven't been watching the side panel. Do we have any questions right now? So with one use case that I think somebody mentioned earlier, looking for specific users that may be tedious in a large company, so using the actual listing in AZ or something might be helpful. The other question that just came in was also regarding database activity monitoring and Lotus Notes. So with Lotus Notes as a specific application, I would say that the database running behind it would be applicable to our analysis. Events from Lotus Notes we can actually collect from our traditional SIEM collection model, and then we can tie those together to look at events from the application and transactions to and from the database behind that as separate values in our analysis. The other question that normally comes up is the requirement to support database pooling. In many cases, a database can't be, when you have an environment where you might have a application server that had a single shared connection to a back-end database server over a single user authentication, and yet that one connection is being pooled for all of the second-tier user authentications. So all of my users log into the app server only logs into my database server once. How do I then peel out the identity of each user in each transaction? The database activity monitor actually has the provision for that exact feature. By issuing certain queries against the database, or more importantly, watching for session information inside the query, we can actually start looking at the appended information for the localized user that's been pulled into the common shared trunk. So that is supported, as well as also things like sensitive data masking, looking for sensitive data that gets returned back from the from a database query potentially, and then determining if in fact the information inside of that is sensitive, and if so, does it need to be masked to prevent any further release of information to even the log reviewer. We have 4 minutes left. Any questions? And Jill, I'll open it to you as well, or Jerry, that can send me messages for the questions. Hopefully what you've seen is the fact that there's a lot that can be done, and most importantly, the fact that it's a very flexible interface. Also, lends itself to the fact that it is a customizable tool that can be deployed in a number of capacities and with many variables. So there's no one-size-fits-all. There's no silver bullet to any of these solutions. Anyone that tells you there is probably misrepresenting the requirements and challenges involved. But a challenge is not something that we steer away from. To us, a challenge in data is something that we appreciate, because our solution really is probably the best one to handle massive amounts of data, unstructured data like it is, and then make sense of it. So we welcome any opportunity to take on the challenge of your environment with your specific data, your use cases, your specific correlation rules, or more importantly, just your performance requirements. Does the SIEM store the application data in the log and event database? So the question there was, where is the data being stored? Well, there's potentially 2 areas of data storage. The first area of storage you think of is the one we're looking at right now. When we perform analytics against information that's been collected by the solution, you're looking at data that's being held in index values. So these are all indexes of the data that was originally collected. Indexing allows me to search it, sort it, filter very quickly, and we maintain almost 26 indexes for every event in our system. And we don't do that at the cost of the insertion rate that most other databases typically do see from the increase in data indexes. What we do also have is the log archive, which would be the place for storage of compliant logs. Those are the raw, pristine, untouched logs. So before we park them, we also ask the question, should these be stored in their original format and content to maintain chain of custody and non-repudiation for the purposes of governance and compliance? And so there's a potentially, if your configuration dictates it, there could be a second log storage location that would be the raw log archive that has been hashed and guaranteed for chain of custody. Bill, I know that you might have a more pressing hard stop at the great point. So I'll make sure that you have any final comments or considerations.
No, I don't have anything to add necessarily, other than I think this demonstration has certainly illustrated the depth that your product can get to, which kind of what we were talking about earlier is probably where we need to be, right? Versus some of the more traditional models of looking at kind of surface data or logs, and only that.
I think what we're finding is very true. Is that the days of a compliance tool being put in for the checkbox of the audit, I think those days are past. I think people are looking to the tool to perform more of what the tool is meant to do, and that is really bring an awareness and help to bring maybe shorter mean time remediations, or at the very least, visibility into the threat perspective and the security practice of the enterprise. And so tools like these need to be very, very diverse in their event collection capabilities, very flexible in their ability to represent multiple types and formats of data very quickly, but also has to be very actionable when it comes to what that data means to you and to the tools that will be referencing that data for impact against the improvement of security posture at the enterprise. So we're finding that more and more visibility is probably going to be the number one goal. Visibility to raw events is one thing. Visibility to meaningful events that have been understood from the perspective of pattern matching and correlation really kind of separates the players of the industry.
Awesome. Well, I think we're pretty much out of time. So if you have any further questions for myself or for Michael, you can actually send them to the letter Q at SANS.org, and we'll make sure we get those to the right parties. And I'd like to thank everybody, and a special thanks to NitroSecurity for bringing this content to the SANS community, to the audience. Again, we appreciate you listening in, and until next time, take care, and we hope to have you back again for the next SANS webcast.